In this video, we'll be going over binary tree level order traversal. So given the roots of a binary tree, return the level order traversal of its node values from left to right, level by level. So in our first example, we have 3, 9, 20, 15, and 7. So at our first level, we have the number 3. So at the first level, we output 3. At the second level, we have 9 and 20. So we output 9 and 20. And at the last level, we have 15 and 7. So we output 15 and 7 for the last level. Let's go through the thought process. We will be implementing an iterative approach of level order traversal. We can create a queue to keep track of our nodes. In each of the level iteration, or in each of the levels, the size of the queue will determine the number of nodes at the current level. Let's go through the pseudocode. So we're going to validate the input parameter. If roots is null, this means that tree is empty, then we can just return an empty list. Then we're going to create a list results to keep track of all node values, and then we're going to create a queue to implement level order traversal. Then we're going to add the roots to the queue. While queue is not empty, this means we still have nodes to process. Retrieve the size of the queue. This determines the number of nodes at the current level. We're going to create a list values to keep track of the node values at the current level. Then we're going to iterate through from 0 to size minus 1, which basically iterating through all of the nodes at the current level. We're going to pull a node from the queue. Then we're going to add node.val to our values list. Then if node.left is not null, then we're going to add the children node to our queue. So I'm going to add node.left to queue. Then if node.right is not null, then we're going to add the right child to queue. Node.right to queue. Then we're going to add our values list to results. Then we can return our results. Let's go over the time and space complexity. So time complexity is O of n, where n is the number of nodes in the input tree, and O of n because we visit each node once. And our space complexity is O of 2 times n. So we still get O of n. This is because of our resulting list and also our queue. Let's go over to code. So we're going to validate our input parameter first. If roots is equal to null, that means there's no node values. So we're going to return an empty list. Now we're going to return now we're going to create a list to keep track of our all node values. And now we're going to create a queue to keep track of our nodes to implement level order traversal. And then while queue is not empty, we're going to create a list of values to keep track of the values at the current row. Then we're going to retrieve the size of the queue, which determines the number of nodes at the current row. And then we're going to iterate through all of the nodes at the current level. We're going to pull a node from the queue and then add the node value to values. And then if node.left is not equal to null, this means we can add the left child to queue. Then if node.right is not equal to null, we can add the right child to queue. Then we can add our values list to our results. Result.add values. And then we can return our resulting list. Let me know if any questions in the comment section below.